Hello, in this video I'm going to go over two ways to calculate the standard cell potential. We got a few questions about this last week, so let's do an example. So in this example, we're being asked to calculate the standard cell potential of this cell. First, let's write out the half reactions of this cell. Remember when looking at the cell diagram, the oxidation half is always found on the left side of the double line that represents the salt bridge, and the right side always represents reduction. So let's write these half reactions out. So first let's write out the oxidation half reaction. So the left side of this cell diagram has manganese, so that means the manganese solid is going to manganese ion plus 2 electrons. And just in case you're wondering, this would be the anode. So for the reduction half reaction, we're going to have the iron. So that's going to be Fe2 plus aqueous plus 2 electrons is going to yield solid iron. And for this one also, in case you're wondering, this is known as the cathode. So there are two ways to finish solving this problem. But remember, once you choose a path, you must continue with that path till the end of the problem. Depending on the path you choose, you're going to use one of the following equations. You can calculate E cell under standard conditions by doing E of the oxidation half reaction plus E of the reduction half reaction. Or you can calculate the standard cell potential by doing E of the cathode minus E of the anode. So first I'm going to work with this left method. If you use this method, you must use reduction and oxidation potentials respectively. So again, I'll write out the two oxidation and reduction half reactions. So first let's find the E of the oxidation half reaction. So remember that E of the oxidation half reaction is just the inverse of the reduction potential. So I'll write the equation up here. E oxidation is just equal to the negative E of the reduction potential. So in this case, E oxidation is equal to 1.18 volts because the E reduction was negative 1.18 volts. So now for the reduction half reaction. Because we're using a standard reduction potential table, we don't have to do anything to change the reduction potential for this. So for E reduction, that's just going to be equal to the reduction potential of negative 0.44 volts. So using the above equation, that would be E cell under standard conditions is equal to 1.18 plus negative 0.44. So that's equal to 0.74 volts. So now let's use the equation on the right. So if you use this method, you have to use all reduction potentials. So now I'm going to write out the half reactions for the anode and cathode, but in terms of reductions. now that we have our two half reactions written as reductions, let's figure out what the reduction potentials are. So E reduction is equal to E anode, which ends up being equal to negative 1.18 volts. And then for the cathode, the E reduction is equal to E cathode, which ends up being negative 0.44 volts. So again, plugging these values into the equation above, you get E cell under standard conditions is equal to negative 0.44 minus parentheses negative 1.18. Notice how both values are just reduction potentials. As we expected, the standard cell potential is the same for the two methods. Remember, if you choose the method on the right, then you must use reduction potentials in the equation. But if you use the left method, then you need to make the adjustment for the oxidation half reaction to get an oxidation potential. I hope this video helped with calculating standard cell potentials, and good luck on your exam.